Like if you have x minus 5 times x minus 4 times x plus 3. This partitions the x interval in the way we talked about at the points -5, sorry, at the point -3, and at 4, and at 5. Okay? Now, a couple of things. This means the graph has to go through this point, and this point. Okay? And not everybody's graph did that. Most did, but not all. Okay? That's one point. Graph goes through all the points. And the graph goes rapidly away from axis to the right and left. And by right and left, I mean you go to the right of the last point to the right, to the left of the last point to the left. You go rapidly away from the axis. It doesn't come through this point and then do this. It comes through this point and just shoots up. Not instantly, but very rapidly, okay? Because it's going to get really big. Another thing, and this is maybe the biggest thing you got to be careful of, you got to tell me why the graph is positive or negative in each interval. I see people just writing pluses and minuses, and I think, half the class, I think, got it right, but the other half didn't seem to totally understand what to do, even though you had the rhythm but not quite the music. So we want to make it musical here, okay? So what do you have to do? On each interval, evaluate to see what each of these is, right? So on each interval, determine the sign of each factor. Okay? That means you have to determine the sign of this, this, and this on this interval. And you have to determine the sign of this, this, and this on this interval. And the sign of this, this, and this on the rest of this, to the right of 5. And same thing to the left of -3. So for example, you could say that between -3 and 4, x minus 5 is negative. Okay? X minus 4 is what? What's -3 minus 4? That's clearly negative, right? What's 4 minus 4? It's 0. So it goes from a negative to 0, right? Or if you want, 0's halfway in between here, and if x is 0, you get -4. You could use a sample point in the middle because the sign can't change except at the zeros. Okay? That's another thing, and let me digress. The graph doesn't go through the axis anywhere else. Okay? So again, x minus 5 is negative, x minus 4 is negative, x plus 3 is what? Between -3 and 4, what is x plus 3? Well, you could say, okay, you can pick a number between -3 and 4. I'm sorry, between 4 and 5. We're looking at the interval from 4 to 5, right? No, we aren't. We're on the interval from -3 to 4. That's what I get when I digress. So back again. X minus 5 on this interval is negative. X minus 4 is negative. What about X plus 3? Negative or positive?
Positive.
Look at what it is at the endpoints, right? 0 here, it's 7 here. It's going to go from 0 to 7 because it's linear. Okay? So it's positive. So when we multiply them together, do we get a positive or a negative?
Positive.
Well, you multiply two negatives, you get a positive, and multiply that by a positive, it's still positive. So I could do this. Okay? If I do these in order, okay? And maybe you want to, at least for the first interval, you draw some arrows that say, okay, this, this, and this, right? Now, on this interval, you do the same thing. Now that you define the order, you do these in the same order so I can evaluate it, right? So you're, at least according to a convention that I'm establishing here, showing me what you're doing, right? You got to show me that. And if you didn't on the homework, you need to fill it in and hand it in again and correct it, okay? You can probably do it on the same page if it's not too cluttered. You know, just show me the differences, because it's essential that you know this. Okay, well, between 4 and 5, x minus 5 is negative, x minus 4 is positive, x plus 3 is positive, so you get a negative, right? On this interval, they're all positive. On this interval, they're all negative, which gives you a big old negative. Meaning now that your graph is negative here, it goes negative to positive, so it comes up like this. It comes through here, comes down through here, and comes back up here, right? Then what's it do? Well, I'll tell you what it doesn't do. It doesn't do this. Now, there are graphs that do. When we get rational functions, which we're going to talk about today, that can happen. But with polynomials, it can't. Because if you think about what happens, big positive x takes you up rapidly. Big negative x takes you down rapidly. So you do this. And maybe you put an arrow on it, because that's kind of conventional. And this slope never, never decreases. It keeps getting steeper and steeper. So whatever you do, you make this steeper and steeper as you go. Okay? And you make this one steeper and steeper. That makes sense? That's how you do this. So, and I think everybody, at least I think almost everybody handed it in. I think everybody did a lot of that, but not everybody did every detail, so I thought I'd better go over those details. So make sure you got them.